Hi, my name's Stephen Brown. I'm a developer on the SC2 framework, and today we're going to go through what your bot can see. So there are a few ways that your bot can interpret the game. There's the RGB screen and minimap, and these are essentially the same as what a human would see. There's a feature screen and minimap. These are sort of an interpreted version of the game, so it shows you sort of layers of information broken down in a way that a computer can analyze it. There's some additional UI information that you would normally see as a human, like when you select a unit, you can see information about that unit. When you have multiple units selected, when you have a building selected, you can see the production queue, those types of things. This information is kind of tricky for a computer to work with because it needs to sort of interpret all the pixels and understand what they mean. Now, the information that you get from the RGB minimap and screen observations, in order to enable these, you pass some information into what's called the agent interface format when you're starting the game. So you specify some RGB dimensions, and those dimensions are the screen dimensions and the minimap dimensions. By default, you can say 84 and 64 is what typically has been used for the screen and minimap. However, you'll probably find that the screen resolution should be much higher, sort of closer to say 512 in order to get a game that sort of really looks like the game. Okay, so the next type of observation that you can get is known as the feature minimap and the feature screen. This information is essentially each layer of detail of the game broken down so that it can be sort of abstracted from each other. These values are supplied in a Y and X format. So you'll get all the Y values and then the X values. That's just the way that the data is sort of retrieved from the game. So that's one thing to keep in mind. There's two types of feature values. There's scalar values and categorical values. So scalar values are usually values that range, from say 0 to 255, and the lower values and the higher values are connected. The higher values will represent a higher terrain and the lower values will represent a lower terrain. The categorical values, on the other hand, each number represents a different category. So it's not necessarily safe to assume that the numbers will be in sequence and that sequence of information will actually get better or worse or, be related to each other. So, you might have, say, unit types, and each unit type has its own number. And, you can have an SCV might be one number and a marine might be the next number, but it doesn't necessarily mean that those units are connected to each other or better or worse than each other. So you treat those values separately, especially when you're working with neural networks. You want to take that information and encode it as categorical encoding rather than, a scalar value, which is sort of a range. Player relative is equal to features.playerrelative.self. And by doing that comparison, what we actually get back is it'll go through and run that comparison against every single pixel and give us back a true or false as to whether that comparison is true or false. And then we can pass that again into a function called non-zero, which will actually give us the coordinates for the ones that are true. And that can be really handy for filtering out information from those layers if you only want one piece of that information instead of all of the information. And the rest of the feature minimap information is all categorical. The majority of the observations for the feature minimap are what are called binary observations. So that means they're either true or false or 0 or 1. There's also an observation called alerts, which I haven't really used, but it seems that it would be used for things like units are under attack, those kinds of things that you would normally get an alert for in the game as a human. Next, we have the other categorical observations. One of these is the visibility map, and this is essentially the fog of war. So 0 would be a hidden pixel on the screen or the minimap. 1 is something that you've actually seen, and 2 is something that is visible. So seen being somewhere that you've been to but you can't currently see. So for the player relative observation, there are 5 values. 0 means none, so there's no unit there or nobody owns that space. 1 is the self, so that's your bot or your own units or your own buildings. And 2 is an ally, which doesn't really apply at the moment because there's no sort of cooperative games, or there's no ability to have more than the two teams. So that sort of isn't really used. 3 is neutral, so this applies to mineral and gas and rock units. maybe Zelnaga towers, those kinds of things that aren't owned by one player or another. And 4 is the enemy. So obviously you'll be quite commonly using the self, the neutral, and the enemy. So when it comes to the screen, there are a lot more scalar values. There's the height map that we saw on the mini map, but obviously you're going to get a lot more resolution. You're going to see only what's on the screen. There's a unit hit points observation, and this has values between 0 and 999, and this represents the unit's health. So this is kind of an absolute health value. So one unit might have 50 health and another unit might have 150 health just because they have the ability to take more damage, that kind of thing. 2 really interesting observations on the screen. One is unit density, and this sort of shows when multiple units are layered next to each other, the value will be higher to show that there's more density there. There's more units in that one space. And this can be kind of handy if you want to see how many units are in an area and that the unit type or the player relative information doesn't really give you that level of detail. So next for the screen, we have the categorical observations, and a lot of these observations are the same as the mini map. So the visibility map, the creep, the player ID, these are all the same as mini map. They have all the same ranges and they essentially function in the same way. So one observation that's really handy, it sort of relates to the UI, things that you can normally see as a human. It's the player observation, and this contains a lot of information that you wouldn't normally get through any of those other layers. So things like the player ID, so which player you are, which can be handy with that player IDs observations that we talked about before. How many minerals you've got, how much Vespene you've got. There's food used, which is supply used, and food cap, which is a supply limit. So you can essentially subtract the supply used from the supply limit and you'll get your free supply. There's food army, which is how much of your supply is given to your army, and food workers, which how much of your supply is given to workers, which is the same as hovering over the supply icon at the top of the screen when you're a human. There's the idle worker count, the army count, so how many units in your army, the warp gate count, and the lava count. There's also some other game information that a human wouldn't necessarily have access to, but maybe kind of knows. There's one called the game loop, which is kind of a computer-only term. Essentially, the game operates at 22.4 steps per second. So the game loop is which step am I on in the game? So the first step of the game will be number 1 or 0 or number 1. And then, 1 second in, you'll be around 22 steps. And this can be really handy for tracking how far into the game you are without really having access to the actual time of the game. You can do a calculation on the game loop and divide it by 22.4, and that will give you how many seconds have elapsed. You enable the feature units on your agent interface format by specifying use feature units equals true. So what information does feature units give you? Well, quite a lot of information. Obviously, the exact location on the screen is really important. It will give you their unit type, their alliance, the cargo space taken, and the cargo space max. There's the build progress, which we now have a feature layer for. The assigned harvesters and ideal harvesters is a very valuable observation. So one thing that does come with raw observations, you get the raw unit values, but you also get some more feature values. So while you can select the units as you did with feature units, you also get some of the layers that you would get from the feature minimap. So terrain height, pathing, placement, visibility, and creep. So all of those values are really handy for making a bot that sort of functions quite well in the game. Okay, so that's it for what your bot can see. You should go and play around with that and see which of the observations you find most useful for what you're trying to work with. In the next video, we'll talk about what your bot can actually do. So take in that information and take an action based on that.